got Yashar from Oranik Engineers presenting first. We've personally been doing business with Yashar for a number of years, and probably one of the best engineers that I've dealt with. Really solutions focused, timber first approach, and incredibly knowledgeable. We're then going to be throwing the mic over to Adam Coombes-Pearce from Wesbeam. There's a nice relationship between Oranik's timber first approach and obviously Wesbeam's offerings, and then we're going to get Yashar, Adam and Mr. Brad McEwen from Sanford Buildco up on stage. So I might hand over to Yashar.
Tonight's presentation we're going to talk about a few things, but what I'm going to talking more a little bit about is the importance of early engagement and collaboration.
Just hold the mic up a bit. I'm struggling to hear.
Okay, sorry. And I spend a bit more time on that one, and then after that I'm talking about a little bit of framing, foundation, and also the performance of the structure. I have some slides, some project example which I'm going to show you, but if I cannot cover everything, please feel free to ask me to go back to them in the QA time so we can talk about them. So as I mentioned, we're talking about the choosing the right engineer for your project. I'm an engineer, so I'm focusing on that one more tonight. It's important who you choose. I know not always the builders are the people who select the engineers for the project, but if you want to take the lead, if you are involved, so it's important who you choose. So there are quite a lot of great engineers, but they need to know your project performance requirements and what do you need from them really. So talking about them, don't expect everyone is on board and everyone has been doing this for long. When I started, we didn't know anything about that. So we learned from the builders, from the architects, from the other parties in the industry. So you can play the role and you can share the message. I'm trying to do that as much as I can these days, but I believe that as a person who's been with the project for a long time, as a builder, which you're going to be on the project for a long time, you can share the message better to the people who are involved in the project. Many times there is one on board already, and even those people, I'm sure if you talk to them, they will be interested to know more and they can help you about that, about the performance of the structure. When we're talking about performance here, it's quite a chunk of it is about thermal efficiency and the long-term performance of the building in terms of the durability and also the moisture management, but also about the performance of the structure. I will touch on that one a little bit later as well. And as you all know, that's there's not, no one can say this is the right approach. There are quite a lot of different ways to get a good result. So there's no single recipe for a project. So as I mentioned, one of the things I found on the SBA newsletter is this carbon pyramid, which it's also is on the website. So for me, was quite eye-catching, and I learned that from the SBA personally. So you can see, I just tried to, because the texts are quite small, I just showing you carbon by volume of the material. You can see where the structure still is sitting, brick red, double fired sitting, and the concrete, hemp, rammed earth wall, straw, or some sort of wood product. So you can see, just looking at the carbon, you can see which one you need to choose when you want to get a result with a lower embodied carbon structure. Concrete, as you see, it doesn't sit very high, but because the volume is really high, so it plays a key role in the embodied carbon of a structure. So I think this can be a good start when you talking about the performance and low carbon building. You can talk to your engineer, your architect, whoever is involved. If you are promoting that, you can give a performance brief to the consultant that you want to engage or you want to get a quote with, and ask them to consider that one. To consider the air tightness, performance, insulation, thermal bridge, embodied carbon, and also design life of the building. quite a lot of high-performance building we design these days, we expect them to last more than 50 years, which is the Australian standard. You need to talk about the collaboration. Like, for example, if the number of the workshop meeting, you need to ask for your engineer, your design team, to have with you to workshop the design and maybe to see where can you reduce things in terms of the cost and budget and how can you detail things, the challenging corner. It's a good idea if these days quite a lot of single houses, they need a civil engineer on board. That's the industry going that way, especially building surveys asking for that one. It's good if you can get one company do both because it's a bit of an integration between the performance of a long-term performance of a building and how is it drainage performance of the site. And if it's not both in one company, maybe it's a good idea to bring them on the table and talk through the challenges each of the engineers may see in the design. Also, if you want to get a good outcome with the collaboration, with the workshop, with the meeting and talking to people, it's a really good thing that we are now doing these days, and this is something came from the architect to us as we give a schematic plan, a schematic design, like a concept design, and then that can be used for early costing and finding the area of the design which requires a bit more attention in terms of the thermal bridging or thermal modeling or maybe some very costly structural items involved. That helps. It's an additional revision with a low cost that can help the project to stay on budget. We believe early engagement pays off. This is like a sample of what we generate as a schematic design. Just identify the main structural member. This is a framing. If there is a freestanding, for example, blade wall, we detail that one, how this is to be done, or how can this be done without a steel, for example. And then that's enough for a carpenter or the builder price the whole framing, with some more schedule, including the studs and the other framing component of the building. Same for the foundation. It doesn't take time, but it also includes some early engagement, workshop, talking through, quite a lot of phone conversation with the other consultants and the builder as well. So the early engagement helps the project is not far from the budget, and also the performance that client wants can be maintained. It's a chance to do some cost refinement in the beginning instead of going to the site and doing those changes. It's much easier, and the project is in earlier stage of the design. The performance of the design can be locked, so we know what we're going to achieve at the end, which is, I believe, one of the things we're talking tonight. And also, we can also make a decision about the structural system that we're using. We had a lot of projects, for example, they started with the hempcrete or hemp block or rammed wall, and they ended up just to be a 140 stud frame, or some of them from 140 stud frame ended up to be 90, or some of them changed to a seat. But the client had to pay quite a lot of consultant fee because of every time design changes, everything is going to change. If it's some early schematic design and cost can be determined, this can be really avoided. And also, when we identify the project problem, quite a lot of reduction in the number of the RFIs and the queries we're getting from the site, because we can see as we spend more time on the job, we can see that on the paper, and then we don't really need to deal with that later in the construction site. Yeah, as I mentioned, builder can do a good costing on the schematic plans as well. So, a little bit about framing. Steel reduction, that's what Hamish mentioned as well. Two areas we see steel in the structure quite a lot. One of them is for the lateral stability of the building, which is my first slide talking about that one. It's quite a lot of projects these days have a high ceiling, raked ceiling, double story, large open area, which doesn't have enough shear walls to be used. You can talk to your engineer and put some suggestion through elements like timber portal frames we're now using a lot. There are now off-the-shelf products which the cost is quite known, LVL column and beam, 240, 300 with some fasteners available with some table of the capacity. It doesn't take much time from an engineer just to read the table and specify on that plan. But many engineers are not aware of that one. So that's, now you've heard it tonight. If I go quickly on the next slide, you can see that. The top middle one is the Simpson strong tie, and the bottom one is the Mayer timber, I believe. They created that one recently. Timber portal frame can also be custom designed, like this is a house, 300 thick in situ hempcrete wall. You can see it's a large open rate ceiling, 45 degrees pitch roof. We have quite a wide glue lamp beam. You can check that glue lamp width compared to the 290/45 rafter we have there. So it's a custom design connection. So this is a bit of a time consuming work for an engineer, so they need to spend extra resources with that one. But for a job like this, nothing else could have been done. It's a very large, open, long living area. We use the kitchen pod as well to stabilize the building, and with some plywood which added later to the building as well. So I mean, these are the solutions that maybe needs a bit more experience to implement, but using off-the-shelf product is quite easy for every engineer. They can specify that one. Vertical trusses, this is something we have been using for a long time, and it's a very good option. PT brace, which is a steel, light gauge steel type brace, which we use as our last resources. It also has table for the capacity and available in the market, and that can be come in small sizes like 300 wide or 350 wide, up to 600 wide with a great capacity that can be integrated into timber frame. That's a very easy use for engineer, for the houses that they don't have enough nib wall or the wall to brace. But it's also a steel, light gauge steel, which we don't suggest that much. But if the project engineer is keen to implement, you can do vertical trusses instead of timber trusses, instead of steel trusses. Like you can see, it can be detailed same as a steel truss, but timber with all screw fasteners, LVL members, some tie down to the building, and so on. It's a bit of a time-consuming again element to design, but it's an engineering first principle design. We use trusses for the roof a lot. It's a mass production, I know. This one can be prefabricated or being built on site by a carpenter. It's not that difficult. It just needs a bit of a time and thinking to design. There are other solutions. For example, we have used timber post, chunky one, embedded into the concrete for the lateral stability. That's an option, can be always implemented. So you bring this all into the conversation with your engineer, and I'm sure many of them, they're keen to hear and use that one. It's not difficult. Double-sided plywood wall now is in AS 1684, clearly with capacity. Some of the engineers used to hesitate specifying that one, but now it is in the Australian standard as well. You can use that one. But the most importantly, as I mentioned, is your input, builders' input about the job. Some of the solutions we offer may not be very practical, so feel free to talk to your engineer and talk them if you're comfortable doing that one or no. That's something you can really address in the early engagement as well. So we're not always wearing your shoes, so we need a bit of input from the site. This is a good example of a job. We had redesigned it back in 2019 in Blue Mountain, New South Wales, open train site. It's been engineered with a full steel frame structure, quite a heavy style, like a warehouse style, a steel UB, a steel column. The house was on a steel subfloor. Most of the house double height with a raked ceiling, as you can see, with a small mezzanine at the back. And the end bay of the house was quite open, with large open window. So we used quite a chunky timber member to do the lateral stability, but we mainly used the vertical trusses to provide the stability for the job. I have more slides to show you. Like you see 4 140/45 LVL studs here as a truss cord and the support of the wind beam. Some laminated top plate as a wind beam to transfer the shear force between the truss structure. So it's doable. It's not an easy solution. It's doable. This has been all prefabricated in Victoria by Carbon Light and transported in Blue Mountain Builder. The client installed quite a lot of it himself. So everything put on the drawings was quite user-friendly. Not easy, but user-friendly. Not easy to design, but really easy to build. We had for this one, we kept the steel subfloor for the job because it was all exposed to open weather. We couldn't really use much timber in that high wind area. Another area which we usually get a lot of steel is floor beams over the large open area or roof beams spanning quite long. 140 timber wall is something we have been using quite a lot, and I think it's getting quite hit in the industry. It's a great thing because it has higher capacity than 90 mil wall, can go much higher. You can hide quite larger timber beam into the 140, like a double 63 LVL as a lintel. You can easily hit into that one. You can have a frame overhang, much more than a 90 mil frame. To have an edge slab insulation, 40 to 50 mil. Usually we need only 90 mil bearing for the 140 studs. Sometimes it's not possible, not for all the projects, but most of the projects we can do that. And for a double height wall, we don't need a wind beam. The 140 stud can easily span up to 4.5, 5 meters of the height if it's just holding a roof. If we can, we increase the spacing of the stud to 600 mil as well. It's still within the AS 1684 and can have the capacity. Like there's no 140 stud schedule into the AS 1684. So this is something an engineer needs to calculate himself. It's a very easy calculation. I think some of the companies, I'm not sure about Wesbeam, I need to have a look. They have tools that you can calculate the studs, and even you can specify larger studs than 90 mil for your wall framing. Longer span deep LVL glue lamp beam. We have used up to 450 deep LVL for ridge beam, for example, and sometimes partially exposed, sometimes it's covered. Glue lamp, you can substitute a steel with larger steel. Some of the engineers, even the one I was used to work with, we had a rule that no timber more than 300 to be specified in the drawings. But and the reason was we were thinking that builders are not happy to use anything more than 300 thick. But we have specified 400 LVL on a lot of projects, and builders are keen to use it. So if you see sometimes everything is limited to 300, just tell the engineer you're keen to use 400 LVL. So you can sometimes you can laminate 445 LVL in a 140 stud frame, span 6 meters holding a floor, even more than 6 meters holding the floor beam, and it's a very easy replace for engineering. I know sometimes the cost is similar to a steel, but the good thing about that is you eliminated some other steels which is supporting the main steel beam, which there are ways to do that which we've been using as well. Like the example I have here, in a project we had to specify larger steel beam. There is no other way to get that to work, but we use 240 or 300 wide LVL as a column. So it's not very usual, but it's a very easy support. You can conceal it into the wall and has the great capacity to support the larger steel beam. The good thing about that is you keep the steel into the warm side of the building inside the thermal envelope, and it doesn't need any insulation or any detailing around that one. So your timber is in the external wall. It has less thermal bridging. It will be wrapped easily and airtight. And we have been using that, and builder working with us very happy with this solution. We have like a timber portal frame over a window, 300 LVL lintel, and supporting a steel beam over. Again, this is something in the industry. Some of us engineers, we think builders will not be happy to adopt that system. But if you are keen to use that, if you're keen to do most of the job yourself, other than the steel fabricated come and finishes his job and leave the site, and you come just connect the other timber to that, then it's a different story. But if you care about performance, you can put the suggestion, and I'm sure your engineer will accept that. There are some more complex solutions. We had, for example, a cantilever balcony in a passive house. We wanted to keep all the steel, we want to avoid all the steel, so we laminated a steel plate with LVL beam so we can get the cantilever. And it was a good solution for that specific project and worked really well. So connection also. Now quite a high capacity screws in the market, and they have all tables and the capacities that can be specified by the supplier or the engineer and can be replaced with quite a lot of connection like stud straps and the bolts. So screws are great and they come in different sizes now, very long screw. We had project, we screwed 240 joists all the way to the bearer with a 300 long screw. So it was a prefabricated job, much easier installation compared to the traditional fixing. So it's another snapshot from the Blue Mountain project. You can see the end bay wall, which is a massive wind beam at the top of the central wall. We had the overhead window, which is a mullion supporting the ridge beam. 140 LVL, 140-63 LVL vertical timber trusses, providing the stability to the building. We had to design some custom connection for the uplift of the truss to the steel beam as well for this project. The house fabricated by the builder, by the carbon lights, but the fixing to the subfloor and all the overhang, heavy detailing has been done by the client on site. It works very well. So these are not easy jobs, to be honest, in terms of the design, but it brings quite a lot of joy and experience. It stays for you forever. So whenever I come back and look at this job, I really enjoy what we've done. So I mean, this is something I'm sure many people in the industry, if they know the client, the project team are open for some more work from the engineer, they're happy to do that. But I mean, it's a bit of a time involved, so it has to be compensated by the project owner. Am I off the time, Hamish? How much? Okay, so we go for a slab a little bit. Thermally insulated slab. Hamish mentioned to me, specifically talk about that one. This is called the decoupled slab. The snapshots here, you can see there is a separation between the footing and the slab, and the fully insulation in between. Sometimes you need to tie the slab to the footing. Depends on the reactivity of the site. Sometimes you can avoid that. Sometimes you need to protect the slab edge because of the soil above it or site condition, but it can be done. It's not exactly Australian standard, but can be translated into the Australian standard. It's a very good system for a fully insulated slab. It's a bit more concrete. That's the cons of the project because of the stiffness of the footing has to be increased to compensate the separation between the footing and the slab for a highly reactive soil. So that's where you get more concrete, but it works well. It works well when you want a fully suspended, fully insulated slab. Another system which quite easy to insulate is a flat slab system, which is the waffle slab is the most common one, but also there are good alternatives like Couple-X, Bi-X, or the recycled pods like with the waffle. There are quite a lot of them in the market these days. So the next slide I can show you a little bit of those ones. The Couple-X is basically a raft slab system, but it's a flat because you have plastic void former between the beams. Bi-X has some similarity to the waffle, but more ribs because the pods are 750 by 750. Anyway, the good thing is they all are flat, so the beam doesn't go up and down. They all designed a standard certified system, so which we can adopt as engineer. We don't need to design them specifically. It's the product, similar to waffle, comes with a bit of a design. It's all about the detailing and where you have that. For example, here we have a large steel We have a large load from a steel column on a widening. A pod is removed, but we are accepting some thermal bridging in that detail because we don't want our XPS to be over-pressurized in that area. Most of the project, they can accept the thermal bridging like this, but sometimes instead of doing that, we put a large pad here. This is a load-bearing stud valve, for example. We put a larger pad to spread the force over the XPS, so XPS doesn't reach to its capacity or near its capacity. No thermal bridging here. You can see in the other detail have a bit of a thermal bridging. Same here. You have a blinding under the edge beam because we want the edge beam goes, for example, to a stiffer material. Our slab panel can sit on a 50 kP or natural soil on many projects, but we want the edge beam goes deep. So here we put some sort of a blinding pad or blinding strip under the edge beams. This achieves, it's a very easy solution, so you can offer to your engineer, and I don't think will be many objection about those type of detailing. One of the reasons many people like to use concrete slab is the performance of the concrete compared to a subfloor system. I understand concrete stumps and the stump pad, a small size, may not perform same as the concrete, but there are really good alternative products for a subfloor. I'm a big fan of a subfloor because it has much lower embodied carbon, much less volume. You can go concrete free or much less concrete. So screw piles, they're getting a really big hit in the subfloor system with some pre-made off-the-shelf brackets, which goes over the screw piles, screwed or bolted, sometimes welded, and then accept a steel bearer or timber bearer. Capacity-wise is much higher than the stump. You can easily get 5-ton capacity over a screw piles compared to like a 1.5 ton over a single stump. So it means you can do using long span bearer, less number of the footing. And because they usually go more than 2 meter, 2.5 meter deep, they perform really well. You're passing the reactive layer of the clay and you don't get much movement. A lot of brackets now in the market are adjustable. I mean, for any reason, if your building experiences some movement, your foundation, let's say in one location, one screw pile fails, you can adjust the bracket and bring back the building to the level. I mean, after, let's say, 40 years, just with adjusting those brackets, you can make your building back to the original condition. Same type of brackets or a stump you can use for over the board piers. Like there are off-the-shelf products like Easy Pier or Easy Brace as well for that purpose, but it doesn't mean you have to use them. You can use just a steel stump and connect it to the board piers in different way. I will touch on that one a bit later as well. Sometimes we use a steel bearer, and the reason is to minimize the number of the foundation, so we can span quite long. 150 RHS bearer can easily go 4 meter double span, continuous span. So every 4 meter you get a screw piles or a board piers for your foundation. What else I have here? So LVL floor joist as well, they span quite long. 140 LVL joist for a R4 insulation, 3 meter continuous span easily achievable. So think about having a grid of footing 4 meter by 3 meter in a small house. It doesn't give you many parts. So some people are scared of the screw piles are expensive or board piers, but if you minimize your framing, floor framing, you don't get many of them. It's much less number to work with. And it gives you the same performance of a concrete slab, to be honest. When your footing are 2 meter deep, sometimes you even can get a better performance than a concrete slab. And you use less carbon, it's much easier to insulate, and it's a really good system for air tightness as well. You get continuous insulation from your subfloor to your stud wall. There are quite a lot of products that doesn't need any welding on site. You can just screw them to your foundation. You even don't need bolts on many of them. Take a screw, for example, a 3 or 4 mil RHS bearer can be easily take a screw to the angle bracket over your screw piles. Very easy installation on site. A few photos like the one at the, I mentioned about easy pier. Easy pier basically is a steel stump on a board piers. So the top one is that one. You can see the adjustable bracket. You can see how it's working. It's quite a large number of the stumps here. If this barrier could be doubled, this number of the piles could be much less. This is not our job. I just got it from the EasyPier website. So the other one is a shore foot system, which is a driven pile system with a small jackhammer. They drive it to the side and then they weld a steel stump on top. And you can accept a barrier or a steel or timber barrier, doesn't matter. Shore foot is also great, has good enough testing and data that can be used by engineers with confidence. They also have a good engineering team. There is an alternative called all foot as well. I think that they used to be the same team, now separated. They also have engineering support. There are some limitations with all foot and shore foot is the length of the pile. So they don't go as deep as a screw pile. So if it's a highly reactive site, I will be hesitating to use them, but for a class M, even class H1 site, they are good products. I mentioned a little bit about the moisture and drainage and civil and structural integration. I quickly just passed that one, not much, but you can see like a site, usually in a lot of projects now you have a site card, you have retaining wall on the boundary, so you have some area of the site built up against your site, so it has to be properly designed, documented, agri drains, drainage system, collect any water is coming toward the building. Even if you don't have a civil engineer as a builder or as a plumber, you need to consider that one and try to avoid, especially for the subfloor system that has to be addressed in the project. Make sure your subfloor don't get flooded. Some area is not that easy to address. This is a decoupled slab, which is raised on that one side of the building, and then you have a deck next to it. Detail like that ensures that the construction goes as per the plan, as per the design. And everything is protected. Your deck is protected, your slab is protected. You have your flashing, you have your connection. For example, here, if you wanted to connect this barrier to this block work under the slab, then you had the insulation on your way for the fixing. So a bit of a thermal bridging. The majority of the thermal bridging, if you avoid a steel in your frame, which you reduce the thermal bridging, but there are always part of the structure connected from the outside to the inside, mostly canopies, pergola, awning, al fresco. So they have to be detailed design when the thermal bridging is important. Like here, there is a awning 1400, which is it's been designed, custom designed, connected to a timber beam outside of the membrane. So membrane comes and covers the stud wall, and then your awning will be fixed to your frame. Or the other one is another awning with a bit of a tie back. It needs a bit of a detailing. You need to ask your engineer for that. So you need to ask, I want an awning that is separated from the building. In many cases, I used to do it myself. I used to put a steel beam here, this FB5 here, and I weld the outrigger to that one. That creates a lot of thermal bridging. It makes it difficult to airtight around that one as well. So that's the easiest option, but not the best option. And that's the majority of the thermal bridging, which is not easy to address as well. To address that one, then you need to insulate the whole your awning, which I don't think anyone likes that. Many of the architects like a slick design awning, not to be that much. It applies the same for the pergolas, which we try to keep a total separation. Thermal bridging has to be addressed for a structure. This is important. And then don't leave the awning for the last stage when the whole frame is built, because you may not find the easy solution. This beam, which now holding a 1400 cantilever awning, in our design has been detailed to have a strong back, or maybe floor joist can prevent the rotation of the beam. So maybe it's not that easy, or maybe it's not holding that much load, but it's upsized just because of that owning twisting the beam, applying the rotation. So if it's come up early, it's much easier to design. Same for the wall framing. Some area you need to do a wall framing, otherwise you end up with quite a lot of steel works. This is a different job from those snapshots. It's a roof that client wants to use it as an attic storage quite a lot. But we're using 240 rafters because of the insulation that we need. So we didn't put quite a lot of underpurlins and quite a lot of props like the conventional system. Truss roof wasn't an option, so we tried to use some larger LVL column with some tie back to the frame. We braced it and it's prefabricated and built. The other one is a 300 wide, again, hempcrete building, but we had a very high end gable wall. We had the whole wall has to be framed. We used 300 high column because from the ridge point to the bottom was around 6 meters, even more than 6 meters, to be able to frame that wall for lateral stability. So these are the things sometimes are missed, and then you get a start schedule in your engineering frame. It tells you 9045 mg/ton up to 3 meters at 450 centers. You are on site and you see there is a wall which goes up to 6 meters, which has not been framed. So if you read the plan, maybe in the beginning, you can identify that one. The start schedule for this type of project is not enough. It has to be designed again. Yeah, it happens sometimes clients wants to use a specific products like hemp block, has to be framed. So be careful with the hemp block. It's a very good product in terms of the efficiency, but needs a lot of framing inside. So this job came to us 2021. We did a full framing of the wall framing all around it to be able to use the hemp block, but the framing cost was quite high, so the project didn't go ahead. I know some people, they use it in Queensland. We were not lucky enough to build one in Victoria yet. Earth construction rammed earth wall is a really good option. It's still expensive, and I think the carbon pyramid was giving it a really good low carbon value for that one. However, unfortunately, quite a lot of projects, they import the clay from the other side of the Victoria just to build a rammed earth wall. So the number in the pyramid may be not correct. It's a good thing if you can use your site clay, but I've never seen that. I mean, they usually import it from somewhere else. Some of the consideration for the performance-based design, sustainability, EPS mixed with concrete is difficult to recycle at the end of the life. So use or ask for plastic pods if you can. That will be recycled much easier. And also use the SBA website. I'm learning a lot from that one. So you can check the material selection tool or how to build a low carbon structure. It's great stuff there. Thanks to you. So I'm learning, and I'm sure everyone can learn from that. Thank you so much.
Thanks everybody. So Adam from Wesbeam Victoria, I'm the state manager there. I've been working with LVL and I-joist for about 20 years now. Carpenter by trade, so I know a little bit about the industry, but not a lot. A little bit higher? Okay. So we'll try and get through this. I'm just going to explain who Wesbeam is and what part they play in the industry. And also what part our engineering team play in the industry as well. So we'll get on with it pretty quick. So who is Wesbeam? We're the only manufacturer of LVL and I-joist in the country. So we're easily identified by our blue LVL and our blue flange LVL I-joist with the OSB brace there. We're the leading supplier of LVL in the country as well. So we're the largest supply chain there. We're manufacturing around 100,000 cubic metres of the product every year out of our Neerabutt facility over in WA. Now, everybody asks why we're in WA. They use very little timber over there. It's all brick and concrete, but that's where the resource is. So when you're trying to make timber products, you've got to be close to your resource. So our facility's built within about 400 kilometres of the furthest log that we take, and we take a few different species in radiata, pinasta, and a bit of carry hardwood as well. Our world scale facility is running 24/7, 364 days a year. We shut down for one. Generally just Christmas Day we give the team off when we work on a 4-shift rotating structure of two 12-hour days, two 12-hour nights, then the team has 4 days off. So it's a pretty large footprint over there. So we control the entire process from the log entering our facility to the finished product going out the door onto the building site. So sustainability is what our key factor is there. All of that log is getting used and all of that product is getting used out on site. So our products are engineered for full structural integrity. Being the only manufacturer in the country, we set the standard for these products out there in the industry. Our whole team is based, our whole engineering team is based in WA, and we're talking the guys who are making the product and testing the product on a daily basis. Our products come as E2S standard, so a glue line termite treatment, so the timidocyte goes into the glue line, and that's what's stopping the termites getting through. There is H2 and H3 LOSP treatments available, so a more prevalent termite north of the Tropic, a Capricorn, will want to eat through that glue line treatment. So that's when we move into the envelope treatments where we pressurise, dip the products into H2 and H3 treatment. So the H2 being a termite envelope treatment, the H3 being a fungicide as well. So that gives you that usability externally. From Perth, we feed our national distribution centres in Victoria, New South Wales, Queensland, South Australia, and WA's facilities there at the mill. We feed into the Northern Territory out of South Australia and Tasmania out of Victoria. There's no point putting plants there. There's just not enough volume going into those markets. We tend to use rail as our first form of transport. We do resort to trucks every now and again when demand is really high, but we like to use the rail network rather than water or trucks. It's just the most efficient way of doing it. We can generally land product from our mill into any of our distribution facilities in less than 10 days. So imagine a tree standing in WA now, roughly about 15 to 20 days later, that can land in Victoria as a finished bit of alveolar I-joist. That's how quick our product is to market, and we're the only supplier of the product that can do that. So yeah, controls the process from sourcing the sustainability forested timber through to delivering the products to the site. So we've heard a lot about in Victoria resources being taken away from the hardwood industry and the likes. That can't happen with Wesbeam. So our resource is a Act of Parliament. So it's actually a law over in WA that they need to give us X amount of resource every month from a certain distance away. And if the WA government steps outside of that, we can actually renegotiate contract terms straight away. So once again, Wesbeam has a resource, the importers have a promise. So when you partner with a company like Wesbeam for your alveolar and I-joist products, you're actually getting a guaranteed resource every month. And with Sustainable Builders Alliance, obviously there's a rebate system, and Bowen's is also our major supply partner in this state as well. So they take the most amount of alveol out of Wesbeam into their sites. 17 of their sites are stocked with our product. We'll talk about the other 2 later on, guys. They should be ours, but definitely the Bowen's Port Melbourne branch has got a full range of our stock over here. So It is ideal for residential and commercial construction applications, including floors, walls, beams and lintels. And we'll just move on. Next one. So timber is obviously renewable, recyclable and biodegradable, which makes it the ultimate renewable product. All the LVL begins with sustainably sourced timbers, using the Penasta, Radiata and Carry hardwood, which are managed under strict Western Australian government guidelines and certified to Australian standards. Our forests always remain healthy and productive for the future. So there's a bit of talk about the Carry hardwood over in WA and that resource being taken away from people. Wesbeam gain access to Carry hardwood via environmental thinnings. So to keep those forests healthy, logs have to come out on a regular basis. So what they'll do is they'll go in and mark those forests really heavily, and decide pathways into the Carry hardwood forest. So they're doing as little amount of damage as possible. There's a lot of black cockatoos over there that nest themselves in those Carry hardwood forests. So Wesbeam work with the WA government and a lot of other authorities over there to ensure that those environmental thinnings come out in the quickest fashion possible and the most sustainable fashion, and allow those forests to keep on thriving for years to come. If you close off the forest and don't do environmental thinnings, literally you will just kill that forest within about 20 years, because it'll just get overgrown and start deteriorating pretty quickly. Oop. That's not us.
Where's that coming from?
Was that your entry music, Yashar?
For kindergarten enrolments. And here's what made the cut: the Aboriginal flag, the Torres Strait Islander flag, the Pride flag, but no Australian.
Ooh, it was a pop-up. No, it was a pop-up in your notes. There you go. You're lucky. Where are we at? Okay, so I think move on. The resource utilisation. So this was a contentious one when they were writing this one. We say we use 100% of the log, but I question that a fair bit of the sawdust gets airborne. But they're going with 100%. And the reason why they went with 100% is that log comes in, it gets debarked at the Wesbeam facility. That material goes off into the mulch sector. WA needs copious amounts of mulch. Like to get anything to grow over in WA, they need mulch on that sand, on that hot, harsh sand. So all of that bark goes off to once it's stripped into the mulch facilities. The log then goes through a peeling cycle, and there's a small core which is about 75mm thick. That core then goes off to particle board, and any waste product will also go off to particle board manufacturers as well. So as in sustainability, we're using every bit of that log possible and trying to retrieve everything. If there's a defective log, once again, that gets marked, and that recoverable volume gets taken off our mark. So when the log does go through the debarking situation, it goes through a scanner which is calibrated regularly via the WA government authority, and that scanner tells us the absolute recoverable volume from that log, and then it's up to us to ensure that we use every bit of that log that we get. You'll see when the peeling goes through, when there's a defect in a log, that you can get little bits and pieces that don't look right. What we actually do is go through another system. Those sheets will go off into a separate line, which we will cut out the defects and start taping that into another full sheet of timber. So we're actually gaining about, since the changeover in the mill of our new system, we're getting about an extra 6% of recoverable volume out of that log that we were then in turn losing to, say, particle board manufacturing. What have we got? So our LVL sections, 90 up to 600mm. Now that it's probably 90 up to 400 off the shelf anywhere in the country. Really, the 600 mil can be a special order, but realistically, Wesbeam's got one thing over all our competitors is we can make pretty much any section size up to 1240 mil deep and 63 and 84 mil widths as well. So we've done some projects with Bowens where we've done 720 by 75 times 4 beams that have created big stadiums for schools and the like. So up to 17.8 metres long. It's up to 12.6 metres long off the shelf in our state as well. Most of the Bowen stores will carry up to about a 7.2 metre long beam as well in some deeper sections. So your standard garage lintels and the likes that are regular section sizes. So we've got all of that in 35, 45 and 63 mil in our LVL. The I-joist, 200 to 400 deep, and we've got the 240, 300, 360, 400, and we've also got some key set-down joists there in the 255 and 265 depths. So when you're doing, say, your standard 300 deep floor system, which is your bread and butter here in Victoria, you can either have a 45 mil set-down or a 35 mil set-down as well. Joist there. Our joists are generally in our core sections of 240 and 300 are available in 45, 63 and 90 mil flange widths, and your 360s and 400s are available in 63 and 90 mil widths as well. The 200 very rarely used, but a 45 mil joist only there. So max spans generally in your 300 you're getting up to about a 6.6 metre span on a standard domestic residential floor. 6.6 you're probably coupled with the smaller centres as well, anywhere from say a 300 centre in that as well. Your 8 metres, we're talking rafters there. This is where the smart guys get in, and I've got one of them here, Terry Chan over here is one of our design engineers that works out of our Australia-wide design centre. So all our designers work from home-based engineers and estimators. So we've got them from the bottom to the top and even over in WA as well. So 5 key engineers in the business with Dan, Tom Rickaby, Dr. Alex Maney, Terry Chan and Jimmy Chang as well there, as well as all our estimators. I think the count is 20. Yeah, 20 here in Australia, and I think roughly 25 in Vietnam as well, working at MyTech Services. They do the base lot of our grunt work over there, and then everything is checked for compliance and completion over here in Australia by our key team. No other engineered wood product supplier has the footprint of engineers and designers in this country and dedicated in this country as well. I think Hamish mentioned the app earlier. Oh no, that was Yashar, sorry. About having different apps to look up stud lintel sizes and that. Wesbeam looked at that about 5 years ago and looked at the cost of what that would be, and we said, bugger that, let's invest in a team. So we actually invested in people instead. Now, the benefit for that was we opened up live chat on our website, so you can talk to any one of our engineers or estimators at the touch of a button via live chat, or you can call our technical hotline and have any of these designs done, as well as a certification emailed to you pretty quick. So having an app is great because you can look at a size, but what do you stand by? Just an app, or do you just talk to an engineer straight out? So that's a completely free service as well with Wesbeam. So that's all covered in the cost of the product when we do it. So yeah, I think we can move on from that one. So design brief optimisation, replacing steel beams, and Yashar hit the nail on the head really earlier. Look at timber first. Victoria has this really old approach of going steel beam, steel beam, steel beam, steel column, and then work out the timber afterwards. Our design team is here to sell timber for us, one thing, is their main point. They will look at every option possible to remove steel out of your job. So, and that's, once again, is a free service. So you can hand over your engineering, your plans, or the even smarter way is just hand over your plans at the start and let these guys do their thing. And then look at if there's any steel that is absolutely required, you will know that it's required because we've tried to get every stick of timber into that job known to man. Other things that you can do is, like you've got your running a mill major builder stuff that are probably designing way out to their deflection limits. We can stiffen up that floor. All you need to do is tell us what you want and we'll design it. We can also look at studs and lintels and the like. So it's a full whole of house design there. The other thing we can do is just look at the way the engineering's running, if it is already pre-engineered, and make some adjustments there for you, and then you can take that back to your engineer and have your plans updated. But the best way to do it is probably the Queensland model. Victoria is far behind the Queensland model. Queensland will not send their job to an engineer after they've got every little bit of free design done possible out of manufacturers and importers and wholesalers and the like. So that's really the model Victoria needs to start pushing to. Sorry, Yashar, but really, there's a lot of free design services and a lot of engineers there at your disposal at companies like ours that can do all this grunt work for you, that you can then take to an engineer and say, this is what I want to do. This is the design that exactly what I want. You just fill in the blanks, obviously, footings and steel beams and the likes, and some key connection details. Just a quick example here. So the joist direction heavily loads the beams, hence steel required. Our team looked at this job and Terry would knock this out in about 25 minutes, free of charge once again. What if we change the joist direction and remove the load from these beams? What's the outcome? 4 additional LVL beams added to the quote, 2 large steel beams removed and 3 steel columns out of the job. So, and this is the sort of stuff that they can design the house and then just muck around with it in the space of like 20, 25 minutes. I think we did one sitting in a cafe for a major builder a couple of weeks ago and removed 4 steel beams out of that job just over a cup of coffee. So that's what Wesbeam, who Wesbeam is and what we do, and we appreciate all the support that we get from the builders in the room, obviously Bowen's and Sustainable Builder Alliance. So thank you very much.
Video, mate. Do we want to take a quick break or just keep going? We'll keep going because everyone probably wants to get home. I'm going to invite Brad, Adam, if you just want to hang around for a sec, and Yashar back up. If anyone's got any questions to throw at any of these guys, shout out. We do have something marked up on this whiteboard here that actually... Oh, you screw all over it. We actually had a question last night on a Future Builder chat about something that we would actually go through with the engineer to workshop, which Yashar talks a lot about collaboration, and I reckon Brad and Yashar over here can probably demonstrate exactly what we would do if we ever came up with a question like this. So the backstory is it's a passive house. The passive house So Jess from Coombes-Pearce had done the modelling on it and was showing that the concrete slab was still at 12.5 degrees or something, and we were trying to figure out how we would introduce more insulation into this particular design by still maintaining the structural integrity of the building, because there is a retaining wall, and obviously with a retaining wall you need quite significant footing. So how are we also insulating that slab by still remaining the structural integrity of the building and meeting all the performance criteria that we're after? So I'm going to chuck it over to Brad and let him run this one.
I'm just trying to draw it so that everyone...
Does anyone have any questions first for Yashar and any of the team about anything they've talked about tonight?
Yeah, just wanted to know, is that getting those the flexible insulations, the use of aerogel blankets?
So say that again?
Aerogel insulation?
Aerogel insulation.
Yeah.
For what purpose?
No, for the floor.
Which area?
For the floor. You can go flexible, you don't have to go to fixed one. And the same for the columns, you can insulate the whole column around the
So if it doesn't have really a structural capacity, it doesn't need to be approved by a structural engineer. I've seen aerogel in the passive house course for insulation. I understand that's quite expensive insulation as well. But I don't think you need to get approval from your engineer about that one at all. No. As long as it meets your R rating and your performance that you need, you should be fine with that one.
Yeah, no, I wasn't talking about the approval, but more about the use. That you can use the columns before this. You can't insulate the columns in the soil because you are using.
Oh, okay. In the ground, you mean?
Yeah.
Not the column. You mean we have a column sitting on the foundation,
Yeah.
like a concrete. You want to use it under the concrete? I don't think aerogel has the capacity to withstand the structural force around the column. Insulating the column, you can use anything. You don't need aerogel. You can, but you don't get your column directly to the soil. You always have a foundation for your column. So you need a thermal break between your column and foundation, which there is a product called Armatherm which they use. If you have a masonry wall like a Randers wall or a brick wall, there is a product called Novamore Block. That's also available in Australia. You can use as a thermal break between your foundation, and that's fine. But if you have a foundation insulation under the slab, that's a different story. So you need to go for a product like XPS or EPS, which has a high compression capacity.
Any other questions?
Yeah, I couldn't see before, but when you brought up the slide with using XPS in between, like the board here and the loft guide, you said, you know, where it's loaded up, you increase the pad size to keep under the pressure limit for the XPS. How much do you sort of need to do that over a standard design?
It's a good question. So XPS on average 250 300 kPa compression capacity. But it also has another factor, which is like a creep factor, which you add to the load, you may get XPS to be compressed. So if your structure can tolerate that sort of compression of like your slab, I was talking with Brad about that exactly. Like in a specific location, if your slab can tolerate that settlement, so you shouldn't be concerned. But if it's a concern, then you shouldn't be letting your XPS get close to its capacity. So your engineer can allow, for example, 150 kPa for your XPS, so it doesn't get the creep or the movement. In that case, it can be easily calculated how big you go. Usually for a structural steel column, we did a few calculations, 600 by 600 pad or XPS below, it gets to where you need. Because you usually, in a clay soil, you usually don't go more than 150 kPa. So if you can keep your XPS in that 150 kPa mark, you're usually fine in cover. Yeah.
Thank you.
Just a question. Energy report specifies XPS under slab and also on the external of the slab on the wall art. How does that work when you've got a brick cap, like a brick veneer, or even a 140mm stud with the overhang of the brick on the XPS? So the external of the slab, it's going to the XPS is 40mm thick, so your brick is going to overhang the slab to the XPS 40mm, and standard's 15. And I'm building on the boundary, so how can you do that?
The best system is decouple the slab for the brick veneer. We have done a few because you have a separate foundation for your brick, and that foundation can be wide enough to tie back to the slab, and your insulation can completely come under the slab and cover the edge, and then you can have your stud overhang for your edge insulation. You can have your cavity, you have your flushing cavity. With decoupled, the slab brick veneer works well. If you have to, in some area, which we had a job, because it was another footing on the boundary, and we couldn't put a footing on the boundary, we had to cantilever the slab. Then if you're building a passive house, you need a thermal break product between your brick and your slab. We explored the XPS, we couldn't find a really approved system to use XPS under the masonry. So you end up with a quite expensive product, which is now only available in Australia is Novamore Block. I think Laros in Sydney, they sell them. If you have a raft slab, that's your only option. But if you have a decoupled slab, are you in the middle of the construction or design?
In construction.
So then if you have a raft slab, you need a thermal break product.
Okay.
Have you got a section detail you can show us?
I'll try to find one, yeah.
But like of what you've got existing, and then we can workshop it.
Yeah, yeah. Yep.
Do you want to draw it?
Well, yeah, the engineering doesn't show the drawing. Like the energy report specifies it, but then the engineering just shows your normal grass slab.
Yeah.
So energy report, you mean, is it the passive house standard?
No, it's not a passive house standard now.
But you're trying to fit slab edge insulation on the boundary, but finish the brickwork flush with the outside of the slab edge insulation. But you can't overhang the brick 40 mil.
So how do I do it?
So you're trying to do the right thing.
Hey?
You're trying to do the right thing by avoiding the thermal bridging from the brick to the your slab.
There's no details. I just don't know how I can build on the boundary with foam and overhang my brick with 40 mil.
And so the outside face of the XPS and the outside face of the brick, that's hard on the boundary line.
Hard on the boundary, on the title.
What's your floor covering?
Terrazzo.
Have you got a slab board already?
No, I'm pouring it in like 2 weeks.
Could you insulate over the slab?
Potentially, but it's probably more complicated.
It's going to change your heights as well.
Yeah, it'll change heights.
It's in that, if it's only one side, in that corner you do a decouple the slab.
In a positive way?
The slab and the footing, make it separate and have the insulation continuous. That's similar to what
It's 3 sides.
Yeah.
Boundary.
From a performance point of view, would be better. Through a passive house lens, it's better. Yeah, because you're using the slab as
if your slab is fully insulated, you get thermal bridging from your brick to the slab.
Yeah.
If your energy assessor accept that one, so that's the easy part. But if you're really insisting of having a thermal bridge free foundation, then you have to change the slab design. Or go the option Hamish said, over a slab insulation.
I have a question about decoupled slabs. Can they go on any site?
Yes, they can. If you need a founding material for your foundation, sometimes you just dig a bit deeper to get your grid of strip put into that. If it's not really in the reach, you do a grid of pile and then put your footing and then your insulation, then your slab. If your top level of material also is fill or not suitable, then your slab will be usually double mesh, a bit thicker, 140, 150. If you have a good soil, natural soil, we stay within 100 thick slab, tied to your footing. Yes, they can.
With this brick overhang detail, could you bolt a plate onto the rebate to overhang that 40 mil to the outside face of the XPS, and then sit the bricks on the plate?
How much overhead?
40 mil. It's 40 mil XPS. 40 mil XPS you're talking about?
Yep, 40 mil XPS.
So you put the edge insulation for your edge of your rebate, but then your brick brings the whatever you're trying to protect, that bricks brings everything back to your slab. So we can do that, but what's the purpose of that? Just tick the energy rating.
I think that's ticking the energy rating box.
Yeah. So that's only that one. Yeah. It's not efficient, but yes, it can be done. But the thing is, you think of a boundary, right on the boundary, how you're gonna bolt that one. So
No, straight down on the rebate like this.
Flat part.
I can't pick it up. But if you just put a flat plate straight down, and then sat the brick sat there, like it was a lintel,
cantilever in the
Yeah.
So these are the exact
even if
discussions
that
that we
needed
would have with
to,
Yashar
even if
in
that
like a
needed
real
to
life
be
scenario.
angle.
an unequal angle, that you then, and then you still maintain your 40 mil cavity here. You can still run, your damp course out or whatever. Got your frame there. Maybe that's bad. Problem solved. What size lintels is
Yeah, that's possible. Yes.
Hey Jesse, we've solved it.
You solved it?
Yeah.
Well, that's good. I need help. I literally came here tonight to ask that question.
That was the cheapest engineering advice you
I thought it'd be better than an Instagram message. I thought it was coming up.
All you need to do now is sign up as a member.
Yeah, I'll sign up.
Does anyone have any timber questions? It's good. You might be able to get it.
Actually, I have a question. So, your engineering service basically, someone send you the design and then you redesign it and certify it. So you have a design and certification. That's what you do.
So
Just for your frame, not the other components.
yeah, so we will certify what we can, and then we would also go back to the engineer to do their certification. So we'll always consult back to the original engineer if the engineer's been involved prior. Yeah, but Terry could probably have a jump.
If they hadn't been involved prior, we'll just send you an architectural plan. And you guys,
We'll try our best to optimize the frame, maybe the floor frame or whatever it is that we are responsible for. And then once we decide done our work, we'll send the copy of the plans, or our plans to you guys, and you pass it on to the engineers, and then they'll do their work, such as designing where slabs, how the slab should be, where it's segmented, if there's some wiring needs to be, that kind of work.
do you certify everything? Let's say you send it prior to initial engineering, you'll certify what you can. Yeah, with 126 or whatever.
So like if for example the project needs a timber portal frame, timber truss, a special fixing, you do that one as well. I mean you can at least you can take the framing out of the. So like my question is, because I know like you guys do, for example, certify your joists or the floor beams. My question is, some of the projects, especially custom home design, boutique building, they need some sort of a wall framing, lateral stability. Do you do that part of the work or no? You just focus on your floor framing and roof frame?
We could, yes, but generally we prefer to defer that that question to the project engineer, who will be involved in designing the slab anyway.
With our partner builders, we'll always go the extra yard because we do have access to the whole of house software. So with partner builders that are not going to just continually shop our price to every supply chain out there, we will always look at studs, lintels, floor frame, you name it. We'll go that full system. So we have a lot of boutique builders who will use us, just say 1 to 2 homes a year, but they're quite large volumes. Their preference is LVL studs and the like, and using our product, so we'll do that. Also with our major builder partners, we will look at optimising their whole of house system as well, because we do find when you go into your cookie cutting or sausage factory engineering systems that they will just pump out standard details, standard systems all the time. So one of our major builder partners, we looked at a range of we took the 80-20 rule pretty much. So what was the 20% of their designs that accounted for 80% of their revenue, and we pulled those apart, and on average we were saving anywhere, I think it was around $17,000 per house in framing timbers, just there, and also a reduction of steel. Wesbeam are also partnering, and we do have patents lodged that we can actually talk about it publicly now, but we are looking at the steel beam killer as well. It'll be a timber LVL coupled with a steel plate, and looking at a flitch beam scenario. So myself, Terry and Tom Rickaby, our technical manager, have now lodged the patent on that product. and we'll be able to look at removing 200 UBPFC and 250 UBPFC out of all internal floor frames going forward. So it'll just be a double timber beam.
Can you touch a little bit? We had a chat with Tom about it on the Zoom call, but just how LVL is graded and like the averaging and then the impact of like different supply chains for the quality of the LVL.
Okay, so this is a bugbear of mine because I've worked across 3 supply chains in this product, and you hear an E rating used quite heavily with LVL. So E13, E14, E15 are probably the key ones. But then you hear branding, so you hear E-beam, Smart Frame, Dindus LVL, all these likes. And I'm going to call Yashar out on this because you talked back to a project in 2019 before, and we noticed that you had high-span LVL nominated on it. It hasn't existed in the country since about 2018. So a lot of engineering firms do get quite confused, and they refer to, say, they might say a 240-63 high span LVL 17 or 15 or whatever. It doesn't make any sense whatsoever. We're looking at standardising LVL engineering in the country because there is no standard for it. Marketing has really got you into a brand of LVL now, and also what we call a modulus of elasticity, which is how the product is graded. People will tell you it's designed as an LVL 15, it must be an LVL 15, which means you need to go buy from this supplier, which is, in all honesty, an absolute load of crap. E13 and E15 are pretty much the same product. An E15 product is designed and manufactured as a 42mm, and E13 is designed and manufactured as a 45mm. It does the exact same job, doesn't it, Terry? Say yes. So we're talking across 13 to 15, we're talking about 2% difference. And what engineer will design to 98% of its capacity? Yashar, how many engineers? None. How many? So lintels in this state are generally designed to about 60% of its capacity. Floor beams, floor bearers, probably at the most 75 to 80%. So when you talk about that little 2%, when it says LVL 15 or 14 or whatever on that set of plans, means crap. You can literally use 13 to 15 as long as the product is certified correctly. Now, we go into the next bugbear of LVL out there. There is a lot of dodgy products on the market. If you walk into a Bowen store and said, "Oh, I just got a price from Joe Blow down the road, and he's $1,000 cheaper over this $5,000 quote that you gave me last week," I can guarantee you are getting dodgy product. You are getting products that isn't certified correctly. It has not followed the correct supply chain. You are most likely getting Russian larch that's sent to China, manufactured there, and then pumped into this country at a really cheap rate. So the big wholesalers out there and manufacturers in this country are doing the right thing, and we're trying to do the right thing, but we're actually getting attacked heavily by what we call the pop-up wholesaler out there, and it's generally a little shed in a back street, and he's buying LVL at probably $600 a cube and selling it to you for $900 a cube, when you've got reputable brands like Bowen's out here who are doing the right thing and making the certification, the PEFC, the FFC certification, all the documentation is done correctly. So when we say, are you buying certified LVL? Well, you are with Wesbeam. We can guarantee you that, because it's all product that comes in from Australia. It's all manufactured here, and it's all certified by our engineering team.
And that's something that's probably not picked up by a building surveyor, because they're just going to walk in and go, "There's an LVL.
There's an LVL.
Happy days."
Yep. Stamping is the key. There's a lot of literature on our website around stamping of LVL. If it does not follow the exact pattern that we have there, you are buying non-compliant timber, and you are running the risk. When we say you're buying non-compliant timber, you can buy that non-compliant timber off a non-compliant wholesaler or retailer or whatever. You take on the responsibility of the wholesaler or the manufacturer of that product. As soon as you are buying non-compliant products, you take on that responsibility of the manufacturer. There's no recall of the person you bought it from. You can go try and sue them, but I can guarantee you they'll shut that business down quicker than anything and start up their next venture the next day. So as soon as you're buying that non-compliant product, just remember, as the builder, you are the manufacturer of that product then.
Question over here.
You you're saying, overall you're the only manufacturer of LVL material in Australia,
Yep.
and you're certifying your own product.
Yep.
So then that, in almost corresponds to what you're saying against European or American-based tilings or whatever it is.
Yep.
Are you then taking all their products as a test subject against your own?
So
and developing products in that
absolutely.
aspect,
So
and then pulling them out, or are they you're having to use them as a standard for Europeans or Americans, whoever it is, as a standard to begin with, right? And then labelling Wesbeam stuff? Or?
So when we, and I say we because I take on the company with heart, but I'll always refer to it as we. But when the plant was started, the Tilling Smart Frame product came out of North America at a mill called Pacific Woodtech, and they are literally probably one of the leaders in the industry in LVL manufacturing. You can see all their stuff on LinkedIn and the likes. They're a really reputable business. Doug Furr coming into that product. Wesbeam saw that as a standard for the product, and they went and said, okay, we need to go 20% beyond Pacific Woodtech. And that's the way we certify our product. We're held to account by the EWPAA, so we're the only EWPAA certified product in the country as well, which means we have to meet their level of certification to get that product. Our technical team over in WA, pretty much if the benchmark is 70%, we raise it to 90%, so we must get 90% compliance. Our actual manufacturing rate is world class. It's 99.3% product compliance with it. So 0.7% we will get a defect in our product, and that may be just a glue, a non-glue failure, but we can catch that before it even hits a site. So 99% of the time, if we have a product failure, we'll actually be able to quarantine that batch of timber in a distribution centre and stop it from going out. Time and date stamp is another thing. If you don't have a time and date stamp on your product, at the exact time and date, you have no way of knowing where that product comes from. Our time and date stamp will relate back to where that tree was removed out of the forest, and that's our chain of custody certification there. So we can go back and say that stick of timber came from this log out of that part of Western Australia. So Source Certain, guys familiar with Source Certain? So Source Certain is now getting involved, and what they can do is pinpoint species of origin of veneer down to about a kilometre radius of where it come out of anywhere in the world. So I think they're up to about 1 million samples of timber on their database, and what they're pretty much doing is random sampling of everyone's product, ours included, via the EWPAA, and they're actually calling out people who are using this Russian larch. So Russian larch isn't illegal in the country, but it is subject to a tariff based on the fact that it is a war. The government isn't strong enough to actually say, no, we're not going to fund the war. They'll say, we will fund the war at a cost at a 35% tariff. And how they're getting around that tariff is sending the logs to China and manufacturing there.
Does that have a question?
Does.
Do the glues differ between each LVL product?
No. The recipe does slightly change. When you manufacture LVL, it is an absolute recipe on the day. So that can come down to humidity in the factory, temperature,
The strength of the timbers,
everything. So we have a glue kitchen there, and a chemist who will literally make that recipe for the day. So it's effectively the same ingredients going into that glue every day of the week, but the recipe might change. So Kathy Morris, our general manager of manufacturing, will tell you it's like LVL's like baking a cake. You have your raw ingredients, and then you put it through a mixing process, and then bake it. And
other LVL suppliers though in the world, like
yep.
Like you saying, like less reputable people.
Yes.
Glues are pretty like big topic, I suppose.
Well, we've seen what we call B. So all LVL should be manufactured with an A-bond glue, so not subject to atmospherical conditions. We have seen products land in the country with a B-bond glue, and mainly in the stud material market, we've seen this come in. Now, B-bond glue literally will break down with water. So it's a myth that if you leave LVL out in the rain or it sits in water for months on end, that it'll deteriorate and fall apart. No, it won't, because the A-bond glue says it won't, and we're subject to 80% fibre failure when we do our tests. So we put it in an autoclave machine, which simulates 50 years of weathering in about 6 hours, and then we chisel it apart and make sure there's no more than it's got to be 80% fibre failure. So any less than 80% fibre failure, we call it glue failure, and it's a failure on us. We will then quarantine that material straight out, and that is done with before the product has even reached the cutting line of our mill. So. And that's every 150 metres. Although that number changes every person this week.
Get some of their special sauce.
Yeah.
Tell them the lock and key.
Yeah.
Any Mick?
If I was to build an LVL frame, let's say my walls have LVL at 140.
Yep.
To get straight for the client sometimes. How long should I build leave that LVL in the metal before it needs to be protected, before it might move and potentially
Yeah.
What's a safe amount of time?
So,
saying 50 years.
Yeah, 50 years. So we actually put a wax coating on our products that doesn't affect glue either. So it's a really good product. So if you're using it on a floor frame, you can glue to it, it'll be fine. But that wax product gives you effectively about 3 months in the weather. If Noah starts building an ark next to the house you're building, you might get a bit worried and start putting a roof on it pretty quickly. But generally LVL, you've got 3 months before you might start seeing some checking or face cracking of the product. It'll still be structural.
Do you expect any movement at time or walking?
Oh, look, it can. Ends of LVL can take on moisture pretty heavily. So.
Paint those if you're building a wall?
Oh yeah, definitely. Yeah, definitely. If you were expecting it to be out in the weather for a long period of time, H3 treatment is absolutely, that's what you want. So water's gonna be taken on. It'll swell a little bit, but it'll also come back to its natural moisture content of somewhere between 8 and 12%. But you will get a little bit of movement there. Your biggest problem with LVL is fungus. So that's when you're using it outside, using a fungicide or a H3 treatment, that stops the fungus growing, because that's what's going to eat your natural product in timber. And that doesn't matter if it's LVL or pine or hardwood, whatever. As soon as fungus gets in, that's when you're screwed with timber.
If you're building for low VOC, so you have got chemical loads in the house, volatile compounds, do the glues produce VOCs?
It's Super E0. Super E0. Yep.
It's the minimum standard that you have for LVLs in Australia, according to RVS 4357. The minimum, for mild height emissions is E0. So, should be pretty safe to handle.
So Dr. Hassan Qureshi will always, he will nominate E0 on our stamping, but he'll actually effectively give you the literature to say it is super E0. Yeah,
so cutting it's no problem?
Absolutely no problems. I wouldn't snort it, I don't recommend it, but yeah, you can inhale it.
Yeah. What about the other treatments? Aside from the glue?
So the glue's fine. I wouldn't recommend drinking H2 or H3 treatment at all. It is recommended that you use hand protection when using it, but cutting it's fine. So yeah, the H3 and H2 treatments it generally a skin irritation is the worst you'll get out of it. So.
Do they gas off at all?
Beg your pardon?
Those treatments have any gassing off in the building?
No.
Any questions?
Cool. I'm up.
On penetrations, like is there rule of thumbs or calculations or tables or something to penetrations within?
Are you speaking for an I-joist or an EB or like an LVL? If you're talking about LVL, the standard does have a limit, like 50 mil. But then if you're going above 50 mil, and there's also rules around where along the beam you're putting it. So if you put a hole closer to a support where there's a lot of shear force happening around there, that's a bad thing. You're likely risking the potential for cracking in the timber, and yeah, you're going to have some long-term issues. Best thing to do is to put it as centrally of the span as much as possible. And the code says that you can put up to 50 mil for a residential house, but if you need to go anything bigger than that, definitely have a chat with your engineer, and the engineer should be able to come up with some sort of reinforcement. It's not really uncommon. Sometimes in like a townhouse build, we might get asked, oh, hey, here's a 300 beam, it's in the way of plumbing, we need to put a 100 mil hole through it. Can you do that? And you know, just we can do our analysis and checks, and then we can see, okay, yeah, we can put a 100 mil hole, maybe we don't need to reinforce it, maybe we need to reinforce it. And the reinforcement is usually quite simple. It's usually just looking like putting some structural ply on each side, and just ensuring that you don't propagate any cracks from having that hole through the timber. But I guess in short, yes, you can put holes through LVL and E-joists. Just make sure you go through the right avenues of checking whether or not it's structurally suitable.
The E-joist is much different. So the strength in the E-joist is in the top and bottom flange through the centre of the span, and the shear is obviously coming through the OSB on the low point. So we can actually get much larger holes through our I-joist than you would get through any solid timber. So generally in a 300 deep E-joist, we're getting anywhere from a 400 by 200 deep penetration through that, and you can get most of the time get two of those penetrations through the one span.
And it's a question to the project engineer.
No, but we can design it in. We can design that in, and we can actually do the pre-cut penetration out of our Dandenong facility and deliver that to you pre-cut in position.
But we're going to let Adam go because he's driving up to Queensland.
Thank you very much. Thanks for your time. It was brilliant to present here.
Appreciate it.
I tell you what, I'm going to wrap it up, but if anyone wants to go through this, like chat through this little detail with Brad afterwards, then happy to, but I'm just conscious of the time. It's 7:20. I might just do a little bit of a wrap up. Obviously, we would love everybody that's here today to join upon as a member of SBA. Look, $600, whatever 30% is off that, like it is such a small fee to pay. One, to help support us, to keep us doing what we're doing. But to be honest with you, if you're not saving that $600 and then some with the offerings that are within that, behind that member wall, like you're not actually utilising that facility as well as you can. I just want to give another shout out to Ultimate Windows. Obviously really appreciate them coming on as a platinum sponsor. Obviously massive shout out to the team at Bowen's. As I said, you know, this opportunity that to partner with you guys has been incredible. And we're also, you know, chatting about a pretty decent event later on this year which we're just going to start unpacking over the next coming months. Don't forget about the podcast. Mr. Simon over there from Sustainable Homes Melbourne as one of the co-hosts with Brian. And of course, check out our website, www.thesba.com, for all the free, amazing content that has been extracted out of Jeremy's head and put onto that website. It is pretty incredible. But yeah, and just thanks to everyone who's come to the event tonight. So thank you.